So today we've got exercise 213, which, like I said last class, is kind of a bunch of repetition and then a bunch of new stuff. And so I'm going to start all the way back where we started with exercise 211 and work our way through exercise 213. So this is essentially the full, all the way through creating the topo model. If you work hard today, I think it's very reasonable that you can finish your assignment 202 digital file. Sorry, I'm making sure I get the numbers correct in my head, which is great. Remember, you do actually have that due. I think it's due on the 20th, so you have to get that done anyway. Frequently, people will post it as part of exercise 213, but not post it as the assignment. I do want two separate posts. It makes my grading easier to have two separate posts. So even if you finish it today as part of your exercise, totally fine. Just make a separate post of it for your assignment from your exercise 213. So you end up posting it twice, and that's okay with me. Okay, so we're going to walk all the way through from the very beginning, which means for the very last time this semester, I hope I have to open SketchUp to get that terrain information. So I'm going to go ahead and open up SketchUp, and I'm going to start using the architectural design feet and inches template. And there we go. First thing, I'm going to go ahead and delete the little person. I don't need to bring her in with the rest of my content. And I'll then go to File, Geolocation, Add Location. And this is where I'm going to pick that location. I did Tahoe last time. Let's do Hawaii this time. Why not? Because don't we all wish we were there instead? So I am picking this completely at random. I have no idea if this terrain is going to work, but it kind of doesn't work because I'm going to go back to the one that I was working on last semester. This is just, or last class. This is just practice. So I've grabbed it. I'm going to go to geolocation. I'm going to show the terrain. Oh, look at that. Looks like I do have a nice piece of terrain. That's good. That works for me. And so with this piece of terrain, I'm going to go ahead and save the SketchUp file. I'll go to File and then Save As. And remember to bring it into Rhino. We need to go back a few versions. I believe the SketchUp 2013 version will work just fine for this. And I will switch over into saving it into today's folder. And this was Hawaii. And I'll go ahead and click on Save. Perfect. So I have that saved. I'm going to jump over into Rhino. And I'm going to, actually, you know what? Let me open a brand new Rhino. I already have the one open from last class. So you don't have to watch me draw every single step all the way around. So I'm going to do a new large object inches template. There we go. And I'm going to go ahead and go to the File menu and choose Import. And from here, I need to go find that SketchUp file. So let's go into my folder where I just saved it. And there is my Hawaii. I'm going to bring it in. These are the SketchUp import options here. I'm going to bring it in as a mesh. All the rest of the options are just fine by default. I'll go ahead and say OK. And that then brings in my SketchUp mesh file, which is right there. See, I go back and forth between SketchUp. I used middle mouse to orbit instead of right click to orbit. Anyway, I'm going to click on the little downward facing triangle in my view here and change to shaded just so that we can see the terrain. Yep, there's the terrain. It looks pretty good. And I'm going to organize my file just a bit before I convert this SketchUp terrain into a smooth NURBS surface. So first thing I need is I need a layer for SketchUp. I'm going to create a sublayer for terrain or SK terrain. And I will create another sublayer here for SK plane. We'll put that on this layer. So let me change object layer. Let me change object layer. There we go. That allows me to turn off all the SketchUp files. It also lets me clean up my layers. So I'll take the rest of all these layers and go ahead and get rid of them. which leaves me with just the default layer and the SketchUp information. Oops. Put this on the wrong layer. Let's put this on the terrain layer. Change object layer. There we go. And we'll turn that off. That gives me just the SketchUp terrain showing. That's it. There's no other objects. So just as we did last class, I'm going to create two new layers. They're going to be called Contour X and Contour Y. I don't want them as sublayers. I just want main layers here. So we'll call this Contour X. And I'll create another layer, and we'll call this one Contour Y. There we go. So I have Contour X and Contour Y. That's where I'm going to divide up this surface into a bunch of lines. So remember, contouring a surface or a mesh is going to give me lines. Contouring lines is going to give me points. So I want to make sure that I am, in fact, contouring the surface here. So we'll go ahead and start the contour command. It's available under Curve, Curve from Objects, Contour. Or I could type in contour into the command line, and I get to the same place. So with the contour command active, I need to select my objects for contours. That would be this mesh that came from SketchUp. I'll go ahead and press Enter. Contour base point is going to be this corner. I can't snap to this corner because I don't have my vertex snap turned on just yet. So let me click on Object Snap, or O-Snap down here at the bottom. I'm going to turn on End, Mid, and Perpendicular, as I normally do. But I'm also going to turn on Vertex, because Vertex is going to allow me to snap to that mesh. So right there, I'll snap to that lowest corner, right there. And when I go off in space here, I want to make sure I'm just along the x-axis. Sometimes it's easier to turn on ortho so you know for sure you're on. It's up to you. So I'm going to make sure I'm on that x-axis. There it is. Distance between my contours, I'm going to do that at 100 feet again. So I'll type 100 apostrophe for the foot sign. And when I contour that, I will get all of those contours. Excuse me. I forgot to put them on the Contour X layer. I created it, but didn't change my layer. So let me right-click and say Change Object Layer, so that all of Contour X is on the Contour X layer. We're going to do a Contour Y, which just means we're going in the opposite direction here. I'll make that layer active first. We'll go ahead and initiate the contour command again. It's Curve, Curve from Objects, Contour. Or I could type in Contour into the command line. Oops. There we go, Contour. Select Objects for Contours. It would be that mesh again. Now remember here, I don't want to select the lines. If I select the lines, I'm going to get points. So we want to make sure we're staying with just the mesh. I'll pick my vertex right there. And this time we're going to go off along the y-axis, again snapping to nothing. And it will once again be 100 feet. And there we go. So I've divided up that surface into a bunch of parallel lines. At this point, we can turn off the SketchUp surface altogether, turn on both Contour X and Contour Y, and we should see a grid that's going to represent ultimately where our surface is going to go. If I were to look at this grid in the top view, all the lines should be perfectly horizontal and perfectly vertical. Actually, I moved my mouse in the wrong direction when I said that, but you guys know what I mean. Horizontal and vertical, there we go. And I need to make sure that I don't have any ragged edges on the outside. So let's take a few curves in. Helps if I hold down Shift like I should have. Go. Take that one at the bottom there. And I'm going to go ahead and type in Trim. And I will trim off the ragged edges on all sides of my object here. I'll go ahead and press Enter when I'm done. And now if I were to look at this in the perspective view, I have a nice clean border all the way around my curve network. So this was established so that I could end up creating a curve network and ultimately a NURBS surface from these lines. Before I do that, though, it's a good place to save because you know that this can cause crashes. So I'll go ahead and go to File and then Save. I'm going to save this on my flash drive in today's folder. go. Now that that's saved, I can start my curve network command. So again, this is all repetition of 211. So I'll go ahead and select all of my curves. I'll come up to my surface and I'll choose curve network. If I were to type this command in, it would be network srf as my command. I get this saying there's more than 100 curves. Yeah, go ahead and proceed. If I did the contour command correctly, I should get 4 sides, A, B, C, and D. That's good. Default options here are fine, and we'll go ahead and say OK. So while this is processing, I'm going to go back to the course website, and I'm going to pull up that cheat sheet. Let me go back a lecture here, or an exercise. Everything's moving slow for me, apparently. There it is. So this is that cheat sheet information. I'm going to go back and reference that as I work through this. So we'll see if Rhino finished its contour. Not quite. Hasn't done its network surface quite yet. Thank you. And so while it's finishing here, we'll come back and we'll look at this cheat sheet one more time. There it is. So this time, as I look at this, I want to know what the size of the physical model is going to be. It's going to be 11 inches by 17 inches. And so depending on what scale I choose, this is going to be the actual size of the rectangle. And so if I was at 1 to 250, for example, I'd come over here and I'd have a rectangle in actual size of 4,250 feet by 2,750 feet. That at 1 to 250 scale would end up being 11 by 17, which is the size of the final model that I'm going to be creating. The one that I chose last time was 1 to 200 scale. That would mean it's 3,400 feet by 2,200 feet. So I want to keep an eye on that. We'll see if Rhino finished. Yes, it did. So since it finished, I will deselect everything. Then I will click once on the middle of my model, and it should select the whole surface. There it is. When it's that big, nasty yellow block, we need to rebuild it so we can actually work with it. So patience is a virtue here. I'm going to go ahead and type in rebuild and press enter. That's also available under the edit menu. So I could choose edit and then rebuild. And I'm going to rebuild the surface somewhere between probably 100 and 200. My guess is that 100 by 100 is approximately where I want to be in terms of the level of smoothing that I'd like to have. If you're worried about how much smoothing, start at 200 by 200 and rebuild again until you feel like you're comfortable. I'm OK jumping ahead to 100 by 100. There it is. I'm going to create a new layer for this. Let's put that all the way at the bottom here. And we'll call this layer terrain. And I'm going to change the object onto the terrain layer. And that will allow me to turn off the contour X and the contour Y. So I'm left with just the nice, smooth NURBS surface. That's the way I want it. So that gets us to approximately where we ended on exercise 211. Now we're going to start with where I picked up on exercise 212. And that's where we analyze the physical model that we want to build. And we reference this handy-dandy little chart here so that I know, depending on what scale I choose, and I want my overall model to be 11 by 17, what size in reality this is going to be. So this time I'll do it slightly different than the last one just for the fun of it. I'll pick 1 to 250 scale. And at 1 to 250 scale, I'm going to have 2750 by 4250. So I'll come back here. I'll choose on the standard tools a rectangle. And I'm going to say at 2750 feet, comma, 4250 feet. Remember, those are both foot increments. And it should have the at sign. So it's relative to the point that I started at. And there's my rectangle. If I were to double click here, I can look at this in the top view. Sometimes it helps to have it shaded so you can kind of see where the hillside is. in this scenario, like that. If I was unhappy with this orientation, I could rotate the whole thing. Just typing rotate, it's a regular rotate, and I could say I want it to go 90 degrees, and then it would be going sideways instead. It doesn't really matter which direction it's going. So I now have it on top of my terrain here, and I want to create this rectangle on the surface itself. And to do that, I'm going to need to project this rectangle down onto this surface. So I'm going to go to the top view here, and I'm going to type project, or I'm going to go to edit, curve from objects, project. I'm going to select the curve, the rectangle here. I'll press enter. Then I'm going to select the surfaces or polysurfaces. There's the surface and polysurface. I'll go ahead and hit enter, and it's going to project that rectangle down onto my surface itself, right there. So at this point, I can go ahead and trim off the extra surface that I don't need. So with that line still selected, I'll go ahead and type trim, and I'll select the surface. There it is. And so now that I've done that, this is ultimately the size of my 11 by 17 model at 1 to 250 scale. So I have my rectangle set, so it's going to be set for that size. The next piece of this is I need to know what intervals to cut my contours at, because I need to know the thickness of that material. So like I said last class, I'm going to suggest that you use the cardboard that's available at the bookstore. It's not that expensive, and it's readily available for us. It turns out the cardboard plus the little bit of glue that'll be in there is about 5/32 of an inch. So to know what the contour should be when I create this model, I'm going to go back to that cheat sheet here. I'm going to look at a contour material thickness of 5/32 of an inch right there. And I'll come down to my scale, which was 1 to 250. And where those two intersect is 39.063 feet. So my contour interval, what I'm going to divide up my terrain with, is 39.063 feet. Now I told you I did this differently than last class because I picked a different scale, just so you can see it a little bit differently. Okay, so I need to go ahead, I'm going to hit escape here, and I'm going to contour this surface with that interval. So I'll go back to my curve from objects, contour, or I could just type contour. My base point will be down here at the corner. My direction perpendicular to the contour planes needs to be straight up and down. So I'm going to zoom out here, either in the front view or in the right side view, and make sure I'm going straight up and down in the Z direction. There it is. And my distance is going to be that value from my chart, 39.063 feet. And I'll go ahead and press enter. And when I do that, it's going to divide up my surface here into a bunch of parallel contour lines. At this point, I'll go ahead and create a new layer for those lines, and we'll call this contour, I don't know, it could be contour Z or it could be topo lines. I'll make those objects on this topo lines layer. I'll right click and say change object layer, make that active, and I can now turn off the terrain layer. That's leaving me with just my contour lines. To double check that I did it correctly, I can always look at it in one of the front or right side views, and I should see perfectly horizontal lines. That means I did my contour correctly. So now it's time for me to go ahead and start drawing the steps that go up each side and down each side. And so I'm going to go back through the methods of drawing these steps, but you guys don't need to see me draw every single step. So once I get these kind of talked through, I'm going to move to the file I worked on last time where it was almost done, and then we'll continue on with exercise 213. So there were two different strategies for how to do the steps. Depending on how comfortable you are, you can pick either one. The first strategy was to create a bunch of points on the ends of these lines. So in that strategy, I would click and hold here. Oh, excuse me. I would right click on the point. That's going to create multiple points. And I would snap to the ends of these lines and work my way up the side. Like that. I'm not going to go down the other side. You guys get the idea. So after I've created all of those points, I'm going to need to select those points. If I reorient my view just a little bit, I can drag a box through all those points. There we go. And I'm going to rotate those down so that they're flat instead of being on edge. So I'll use the rotate 3D command to do this. It'll be transform and then rotate 3D. I'll start at this low point right there. I'm going to go right along the y-axis in this case. And I'll go straight up and down. And I'll just fold those over so that they're now flat on the ground. From here, drawing the steps is pretty easy. Let me create a new layer called steps. We'll make that active. Sometimes people like to change the color of the steps, so you could change it, for example, to red, just so you can see that you're drawing. And I would start at the first dot. I'd go off perpendicular to where I met that point. Oh, I need to turn on point snap. So I'm snapping to the point there. And I want those to be perpendicular. There it is. Perpendicular. Keep going. There's perpendicular. Perpendicular. Etc. When I'm done, I'd press enter. And I'm going to take all of the dots and the line, the steps that I just created, and I'll go back to the rotate 3D command. So I'll go up to transform, rotate 3D, start at the same point, go along the y-axis, go out to the side here along the x-axis, and fold it back up in the z direction. If you do it correctly, when you fold it back up, you should see the steps rather clearly, and they should all look parallel to one another. You can double check your work by looking at the steps in one of the side views, and they should all look like a series of steps. If you see them off on an angle, something went wrong. So, as I'm knocking the microphone off here, that was one method of doing it. The other method, and I'll switch over to the other side here to show you that method. The other method was, instead of creating the points and rotating them flat, was switching the drawing plane from being flat to being along the side of our model. And so that drawing plane is called the C-plane in Rhino. It's called the UCS coordinates in AutoCAD if you're familiar with that. And so I want to switch that to be along this side. And I'll do that by clicking on the triangle where it says perspective. I'll come down to set C-plane. And remember, world top is the default. So when in doubt, start with world top. So I go to world top. I know it was already there, but just in case. And then I'll go to set C-plane 3 points. And when I choose to set the C-plane 3 points, I'm going to pick one of the ends of my contours here. And then I'm going to go off in this case, it would be the negative y direction, basically along the length of my side here. And my next click needs to be going vertical. And I can't get to vertical in this view. So I'll go over here, and I'll go to vertical in the front view or in the right side view. So again, I'm not snapping to anything. I'm just using my axes and my ortho to make sure that I'm in line. And once I'm done, my little grid will change to be on that point. And you can kind of orbit around to confirm that, yes, it looks like it's in the correct orientation. If you're struggling to see enough of the grid to know what the orientation would be, you can always right-click on where it says Grid Snap down here at the bottom. Go to Settings. And you can change the grid line count to be higher. So like add a 0, for example, or add 2 zeros, and you'll get a bigger grid. I'm going to leave it just at that size because I think that's big enough for me. And we can say, yeah, that looks like it's in the correct orientation. Now I can go ahead and directly on these lines, I can go ahead and draw my steps. So I could start here and work my way up like that. If I did it correctly, I should be able to see this in the side view, and it should look like a series of steps. So that's good. So like I said, I don't want you guys to have to watch me do all the sides of this model, so I'm going to switch from this model to the model I worked on last class. So we're jumping from Hawaii back to Lake Tahoe. And in this scenario, I've gone ahead and I've finished the stepped sides. I haven't worried about the corners just yet, but I've finished the stepped sides. So let's go ahead and take those stepped sides, and I'm going to put them, if they're not already, on their own layer. Go to my layers here. Oh, they are on the step 1 layer. So that's a good thing. So we just got to where we ended last class. So it took me the first 20 or 30 minutes to get through where we were. Now we're going to start going forward into making the actual laser cut file. And how do we create? So before we get to the laser cut file, we have to think through what's happening in the corners, and also are there any mistakes in our steps. So I'm going to carefully go around and look at all the sides. And I'll start here with this corner. So in this corner, we have a step that comes down, we come out, and we hit this contour, which is kind of right in the corner, and then we come across and we keep going back up. So in this scenario, there is another step that occurs at this contour. It would go down. So let me go ahead and reset my C-plane. So go back to Set C-plane, World Top, and then I'll come to this corner and I'll reset my C-plane again. So I'll go to Set C-plane, 3 points. I need to turn on my object snap here, end, mid, and perpendicular, and I'll snap to this point. I'll turn ortho on, I'll go off in space this direction, and then I need to go up and down vertically, so I'll switch my views, and there's my C-plane. So this makes it easy because I can go back to my line tool, I can start here, I can draw down by whatever my contour interval was. I know what that is, it was on that chart over here. I was working at 1 to 200 feet in that model, so my contour interval was 31.25 feet. So I can simply draw down 31.25 feet, like that. Then I will draw just going off past the corner in this direction. So I end up with a step that starts at the last contour, goes down, and just goes long. We'll come back and we'll trim that off a little bit later. Now I need to start at this step and go down and over. So once again, I can reset my C-plane. I can go to Set C-plane, World Top, and I could reset it for 3 points right here. Sometimes people get annoyed having to reset it all the time. So I can technically do this without resetting the C-plane by choosing this point and then switching my view into one of these side views and typing in the 31.25 feet. And you can see that it just drew it down. I switched views and it did that. Then I'll come over here and I'll snap to perpendicular. That then creates this last little piece of the corner right there. Obviously this line is long, so we'll need to trim that off. I'll type trim and get rid of that piece. So this step right there can be joined up so that that's one side. I'll type join. And this step here can join into that side. So that came down rather nicely, and I met at a corner. Every once in a while, you'll get lucky, and one of the contours will meet exactly at a corner. But it doesn't always happen. So let me come back to this corner. OK, so on this corner, it's the same scenario. I've come down after steps, and I end up ending on this little tiny contour in the corner. So let's be honest. If I were to laser cut this file and cut off that tiny little piece would get burned up into ash. It's not going to make anything for me. It's not going to look good. It's not going to do anything for me. So I'm giving you permission right now to, if you have a little corner like that that's going to get in the way, go ahead and press that delete key to make it go away. Because it's going to burn up and you're going to lose the little piece and it's not going to be worth it. So we'll go ahead and ignore that. In which case, this corner got really easy. We just need to extend this line that direction and extend this line in that direction and trim the result. Now, if you paid attention earlier in the semester, you would know that the other option would be to use a fillet with a radius of 0. So I typed R, enter, and then 0, enter. And you could connect those two lines in space without having to worry about it. And that then builds out those two. So it's a faster way of doing it. Could you add those line segments, trim them, and join them? Sure, not a problem. So one more time, I set that up with a fillet. Instead of the curve happening, fillet has an arc between the two curves. I've set the radius to 0, and then I click the first line and the second line, and those two come and meet at a single point. So I've now established that corner. Time to come down to this corner. And so this one's interesting. It's kind of right on the borderline of whether this is worth cutting it out or not. I'm going to go ahead and draw it in, and we'll take a look at how small that little sliver is before we decide to get rid of it. So in this scenario, I would start with my polyline tool. And again, I could reset my C-plane and draw down, or I could switch into one of the side views and go ahead and draw straight down 31.25 feet. I have to click so that it's going in the correct direction. There it is. And this one goes off in space that way. I'll come back to this point here, and I would draw going down again 31.25 feet. And then this will come over and meet at perpendicular right there. I need to do a little bit of extra trimming, so we'll type trim and get rid of that extra piece. And so now I have this last step connected to those steps, so join, and this last step connected to this step, join. Okay, so I've got this corner resolved. That looks good. I've got this corner resolved. That looks good. I've got this back corner resolved. That looks good. We come back to this point right here. So this one, I ended up skipping a few contours. So I have to think about how this is going to come together. This bottommost contour, again, might get burned out. It's not that, it's kind of small. I'm going to go ahead and draw it in. We'll see when I actually do the laser cut of this file. So this is the other thing to look for, besides the corners, is to look for places where you either are at the bottom of a set of contours or at the top of a hill. So at the top of a hill, we're going to come up to our contour, and we're going to go straight across and then keep going. And I think the easiest way of seeing this is if you imagined these two contours were the edge of a piece of cardboard. This would continue out here and then come back and connect to that piece. And all we're doing is cutting it off because that's the edge of our model. So it's easy to see that this contour ends up being the same height as that contour right there, which is the same height as this contour right there. We're just choosing where to cut it. At the bottom of a hill, so here's the bottom of a valley, this contour would keep going off here, and this step is actually below where those two contours would be. So anytime we get to the bottom where you have two pieces in a line, you need to go down, over, and back up. So this point would be the same thing. I need to go down, over, and back up. So I'll start with my line right there. I'm going to go down here. Again, I'm just going to use my front view, 31.25 feet. I'll go over, and I'll go ahead and make this one a little bit long. So I'm snapping there to that point. I want to make sure I'm not snapping. There it is. And then I can start at this point and come down to perpendicular, like that. And so we can see the step coming down. There's the step. I'll trim off this edge. Alternatively, I could use a fillet and that then creates this horseshoe at the bottom. So I'll go ahead and join those together. There it is, and we can keep working our way up. So the next one would come over. Again, I'll leave it long. This one would come down. I'm just snapping to perpendicular. This one would go over, and I need to connect those together. I could use the fillet command with a radius of 0 to connect this to this as it goes up. So I'm working my way down, I'm working my way up. This corner, this needs to come down and then meet up with that line. So I'll start at this point here. I'm going to go down by the 31.25 feet. There it is. And I'll come over to perpendicular like that. So I have this plus this. I'm going to join those together. I have these lines on this side. I can join those together. I need to trim off that extra piece there, so I can either select this and type trim, or I could use that fillet command again to sort out that corner. So if I look all the way around my model, double checking, that's at the peak, it goes straight across. This one is at the trough, it goes down and over. There's the peak, there's down and over, there's the peak again. That goes down and over and back up, yep. That goes there, these go down here. Those two meet at the corner. This works its way up this side, goes across there and back down, and that meets right there. So I've gone all the way around my model. I feel confident that my sides are correct. If you struggle with a side or you can't sort out what happened, ask me and I'll go through it with you and we'll sort it out. There are scenarios where, let me go ahead and where you end up making mistakes. And you might have something like this. So you came up this side here. We came across, and you forgot to go down. And now all these steps, they look right. And they go down, and then they go straight across here, and then they continue back up. But you say, wait a minute. This should be going down here, and they should be going across there. When that happens, even if it's a continuous line, go ahead and type explode. But don't deselect everything. Select or deselect one of the curves that's right next to wherever the error happened. So that would be the place where the error happened. Then go back to join. So I've deselected a segment here. Then I go back to edit, join, or I type join again. That keeps the other two segments still attached to one another. And then I can move just this segment. So I can move it, and we'll snap that down to where it's supposed to be. Then I can add back in the line segment that should have been right there and select the first like that, and then join all of those back together into one. So sometimes you end up off, it's okay. Remember the explode, deselect a line, join, and then fix the problem. So again, if you run into trouble, it's okay. I will help you through that part. Oh, looks like I still need to connect this down here. That should be joined. That looks good too. So our goal is to have all the steps done and to have just one joined polyline that represents each of those four sides, which is exactly what I have right here. So one joined polyline. Okay, so now it's time to start thinking of this as a model. It's still at full scale, but we're going to draw a little bit as if it were a full model. So I have this side here. This point right there is my lowest point. I've kind of looked around. I can see that everything else is above that point. So I'm going to start at my lowest point right here. And I'm going to draw a line that goes down at least one contour, maybe two contours. Does it really matter how far? No, it can be completely arbitrary. So I'll draw it down maybe about like that. About like that. I'm going to draw across there. I'll start at this corner with my line right there. I'll draw straight down to where it snaps to perpendicular. I'll use a fillet or a trim so that that goes together. And what you should see now is this plus this plus this is now one side of my model. Do you see that? We'll go ahead and join that side together so it's one complete side. Now we'll start on this front side right here. I will start with my polyline tool. I'll start at the same corner. I'll draw down, snap to this point. I'll draw long. I'll start at this point on the opposite side. I'll draw straight down, snap to perpendicular. There it is. Fillet again. I'll fillet this to this. And so now I have that curve plus that curve plus that curve. If I join them together, that's my next side of my model. Can you see how this is starting to look like the model that I built, the cardboard? So that's exactly what we're doing. I'm going to keep going. I'll start here with this corner. I'll draw down, snap. Sorry, it didn't look like it was quite on the corner. There we go. To right there. Go off in space to there. I'm going to start at this corner, and I'm going to come down, snap to perpendicular. There it is. Fillet from there to there. I'm going to take this plus my steps plus that piece and join that together. Last piece is this back. This time it's really easy. It's from this corner down to there, straight across to the end and back up to there. That'll give me this horseshoe and that piece, which I can then join together. So I've now created all four of the sides that I need for my model. Oops, that piece didn't look like it got joined. There we go. So I have all four pieces that are the sides of my model. At this point, I can go ahead and fold those sides flat. Now the key here on the folding flat is that you just want to be consistent. It doesn't matter whether you fold them in or you fold them out, but they all have to go the same direction. So I would take, somehow to me, folding out seems to make more sense. So I'm going to go ahead and use my Rotate 3D. So I'll go to Transform, Rotate 3D, and I'll pick the bottom of each side as its rotation axis, and I'll fold each one down. So I'll repeat and go back to Transform, Rotate 3D. And I'll fold that one out. Come over here to this one. Same thing, Transform, Rotate 3D. That one's flat. Last one here, Transform, Rotate 3D. And we'll fold that flat. So I now have all four of those sides folded flat, and they're all consistently folded out. So I have those pieces. That's great. The next piece of this puzzle is I need all of these contours to be flat on a single plane. They can't be up anymore in 3 dimensions. So some people at this point like to just make a copy just in case. So I'll go ahead and do that. I'm going to take a copy and I'll drop it over on this side. You may even take the copy before you fold them flat, so you could always go back to it if you wanted to. And now I need all of those topo lines to be flat on the ground. So we did this briefly in exercise 211. We're going to use the project command to take all of these lines to a flat plane. So I'm going to go ahead and create a new layer, and I'll call this flat topo. And on that flat topo layer, I'm going to create a rectangular surface. It's just going to be a rectangular plane corner to corner. I'll make it larger than everything. And then I'm going to go ahead and look at it in my top view right there. This is where the projection needs to happen. So I'll go ahead and select all of those lines, except I don't need the corners. I just need all of these, and I also don't need all of those little points. There we go. And so I'm going to use the project command. I'll go up to curve, curve from object, project. I'm going to project those onto this surface, and I'll go ahead and press enter. And that's going to create a flat version of all of those topo lines for me. I can move those away so we can see them a little bit better. There you go. They're all flat. We can delete the surface because we don't need that. So I can now look at this set of flat lines, and I can start to think of this as a laser cut file. So the way that we're going to do this, and I can go grab one of the examples from my office, is that we want to preserve material. And so could I do cutouts with each topo being an individual sheet of cardboard? Yeah, I could. But it would take like 20 sheets of cardboard to make all those pieces that stack up. And I've seen people do models like that. And to me, it's a complete waste of cardboard. We don't need that. We just need 1 sheet or 2 sheets of cardboard max. And so what we're going to do is it's kind of like shuffling a deck of cards. We're going to cut every other contour as we do it, and then we'll make a second copy of these contours and cut the opposite. So there'll be an engrave line and a cut line. So I'm going to start here, create a new layer, and I'm going to call this one laser cut. There we go. And on the laser cut layer here, I'm going to create 2 sublayers. One is going to be cut, and the other is going to be engrave. So I have a laser cut layer, I have cut, and I have engrave. The cut layer should be red, so I'm going to change the color to red. The engrave layer here should be blue, so I'll click and I'll change the color to be blue. If you use red and blue as your 2 colors, those are the correct colors for the laser cutter. It will recognize those correctly. Okay, so in this first version right here, I'm going to start at a low point. And it doesn't matter which low point I pick. Ideally, it would be the lowest point, which is right there. And I'm going to start by selecting every other contour line. So I'll start with this first one. I'm going to hold down Shift, and I'm going to work my way up my contours. And this, unfortunately, is a little bit tedious as we work through. And I'll work my way all the way to the peak. Now, I did work my way to the peak, but in some cases, the contours go back the other direction. This one's fine. But here, I would need to select that contour. And going down this hillside, I would need to connect these guys. Going down this way, it would be these. Down here, it would be those 2. And down here, it would be, whoops, those. So once I have all of those selected like this, I'm going to go ahead and change those to be on the cut layer. So I'll right click and say change object layer, and those are now on the cut layer. I'll do the opposite, and I'll select through here. All right, I've selected all of those. Those will now be on the engrave layer. So I'll right click and I'll say change object layer. So I have a drawing that looks like this, my topo lines. And I've started with the cut at the lowest point, and then I've alternated every other. So when I actually cut this out, the cardboard is going to be cut here, and it's going to be cut here with an engrave line in the middle of those 2 pieces. So if I make a second copy of these same topos, go ahead and copy, and I'll put it just next to it here. If I flip-flop these, if I take all of the blue lines and I make them red, and I take all of the red lines and I make them blue, I'm going to cut the exact opposite from one to the other. So again, this is a little bit tedious in terms of the selection process, but we'll have to go through and once again select them and change them. Sometimes people like to use an intermediate layer to do this, so you can select by layer and then not have to select them individually. I'll show you how to do that. The alternative would be to do what I just did and select the opposites. So in this scenario, I'm just going to create a third layer. I'll call that temp. Temp, sorry, can't type. All right, let me select all of the cut layers. So I'll right click on cut and I'll say select objects. There it is. It's going to select all of those. I'll hold down Control and I'll deselect those objects. So that was my first one. I'm not worried about it. I still have them selected on my second copy. I'll right click on the temp layer and say change object layer, and those all went to the temp layer. I can turn off the temp layer, and that leaves me with just the blue lines. These blue lines are the same as this topo set. These blue lines here just need to go on to the cut layer. So I'm just moving their layer. I'll right click and say change object layer. Now all of those are on the cut layer. I can then turn back on the temp lines. I can right click on temp and say select objects. That selects all of them. Those needed to be on the engrave layer, so I'll right click on engrave and say change object layer. That's the most efficient way of doing it. Could you go through and manually select them and change them that way? Sure, not a problem. You get to the same result. It just takes a little bit longer to do it that way. So I can verify that these are the exact opposite of each other. So if I started here, this is blue, red, or excuse me, red, blue, red. Over here, it's blue, red, blue. That's the way that they should be. So I want two that are opposite each other. In order to cut out this overall shape, I need a rectangle that goes around all of it. So I'll use my smart tracks from there to get that corner. There's the corner. Smart tracks again from here to here to get that corner. This rectangle needs to be on the cut layer, so we'll change object layer like that. Same thing on this side. So I'll use a rectangle and we'll snap those two together. Smart track those two together. And this once again needs to go on that cut layer. So let me go to change object layer. And there it is. These are the two topo pieces that need to be cut out. These sides also need to be cut out. So I can take all four of those sides, and I can change those sides to be on the cut layer as well. So I'll right click and say change object layer. And those are now, let me just move these off to the side, on the cut layer as well. So I've just created all the pieces that I need to cut out. The problem with these pieces is they're all still 2,000 feet long. They're not down to the scale that they need to be. So remember that this side needs to be 17 inches. This side needs to be 11 inches. Same thing for these pieces. So at this point, I'm ready to move on. I can take the whole thing. I'll take everything. And I'm going to go up to transform and then scale. And this is just the regular scale. It's a scale 3D. Everything scales at once. So I could type in scale. I'm going to choose my origin point right along this top edge of this one. So I start right there. My scale factor or reference point, my reference point would be to right there. And I want that to go from being whatever it was, 3,400 feet. I want it to now be 17 inches. So I'll go ahead and type the 17 followed by the quotation mark for inches, and I'll press enter. And when I do that, almost everything disappears. That's because it went from being 3,400 feet to 17 inches. It's a big change. Everything's still selected. I can type Z for zoom followed by S for selected, and I can see all of my same drawing again. If I wanted to verify that these dimensions were correct, I could type in distance, and I could measure, say, from there to there, and yep, it's 17 inches. That's good. The distance from here to here should be 11 inches. Yep, all is good. So I now have the pieces that I need to cut out. It's just a matter of laying them out on a board to get ready to laser cut. The laser cutter bed is 12 inches by 24 inches. So I'm going to go ahead and create a rectangle here at 24 inches, comma 12 inches. Sorry. How about at 12 inches, comma 24 inches? There we go. It has to do with my orientation. I was backwards. And with that 12 by 24 laser cutter bed, I need to arrange and fit these parts. And it might be even easier to see this in the top view now. Let me zoom selected. There it is. And for clarity purposes, to make this a little easier for you guys to see it, I'm going to rotate everything just so that it's looking like that. I'll take this first one. I'm going to move this so that it fits inside of the laser cutter bed. Like that. I don't want anything right on the edges. I want to leave a little bit of space around the laser cutter. For those of you that have laser cut before, you know it's good to leave at least 1/4 of an inch around the outside. That's good. I'm going to copy this. That's my laser cutter bed. I'm going to end up needing 2 more, I think. This one here, I'm going to need to move this one. Let me turn off ortho here. Same thing. I've got my 4 sides. I need to move them. It doesn't matter with the sides if I end up rotating the pieces to fit a little bit better. Sometimes that's the best strategy. You just don't want to flip them over. So no mirrors. So let me rotate this one. Oops. My ortho was turned off here. And let's move this one over here, like that. So I now have the pieces necessary to cut this particular file. So this is what we need to go over to the laser cutter. This is what you're going to be turning in when I say digital file. So a couple things. One, I would like a screenshot of this. So once you have it at this point, click on this triangle and go to Capture to File. This is going to prove what it looks like. It makes it easier than me having to download every one of your AutoCAD files and verify that it's there. I can just see the screenshot and know it's there. So you'll save this as a JPEG. Then you're going to take all of this and go to the File, Export Selected, and you're going to put it into an AutoCAD file. So we're going to go out of Rhino into an AutoCAD DWG file. The AutoCAD DWG file, the options are, I'll show you that in just a second. Let me go ahead and give it a name. We'll call this Spring of 2019 Laser Cut. Let me put it in my flash drive where it belongs. And I'll go ahead and click on Save. When I do that, it's going to give me the DWD DXF export options. Believe it or not, the default options work fine. I've found good success also with the 2004 polylines. That tends to work pretty well as well. So I'll go ahead and click on that and say OK. And it's going to write an AutoCAD file for me. I can verify that the AutoCAD file worked. Yes, this is not an AutoCAD class, but I can still double click and open the AutoCAD file. There's nothing wrong with that. Let me go ahead and find it. And it was right there. There's my laser cut file. I can double click on it in AutoCAD. Yep, go ahead and open in AutoCAD. Maybe not. Now that AutoCAD's open, let me see if I can open it. OK, because we created the file in Rhino, AutoCAD throws the error You created this file not in Rhino. Are you sure you want to open it? Yeah, of course I'm sure I want to open it. So we'll go ahead and continue opening that file. And we'll give it a second. And it should show up with our drawings right there, which is what we want. This is exactly what we need to laser cut. The only thing that we don't have set already for us is the line weight that's necessary, so the thickness of the lines. You can do this over at the laser cutter machines, even in the viewer application that you do the cutting from. So you don't need full AutoCAD to do this. It's just a matter of going to the layer properties and changing these two layers, there and there, to have a line weight instead of default of 0.00. So we'll change each of those to 0.00. That represents a cut line in AutoCAD. The colors are all correct. We don't worry about the flat topos or the layer 0 in AutoCAD. It doesn't matter. Those aren't going to cut anyway. And so as long as those are 0 zeros, we're ready to cut. If you have never cut, that's okay. There are supposed to be lab technicians that can help you do your laser cutting. I can also help you during class time or during my office hours if you struggle with that. I don't think it'll be, it might be next class, it might be the class after. I will go ahead and laser cut this as an example, and I will show you how to glue it together, because seeing somebody glue it together can help you. There are certain tips, like you glue the sides together first before you glue the topos on top of the sides, and you'll get better results than if you do it the other way around. Yeah?
You said you're going to glue it next class, or the one after that, but isn't it due next month?
The digital file.
Just the digital file.
Just the digital file. So just the digital file is due. The physical model isn't it's due the Wednesday after spring break. So there is online on the course website, I do have a recording that I did of me several years ago gluing it together. It's actually kind of entertaining because the people who gave me the glue bottle didn't put the lid on all the way and it explodes halfway through on me. So, thanks a lot to those guys. No, I don't think it was intentional, but no, I don't have the exact timestamp. You'll have to watch it. Sorry. But anyway, it happens. So the video's there. So if you miss me demoing it or you want to get a head start on it or whatever, that's fine. When you finish it, I do ask that you keep it yourself until the day that it's due. On the day that it's due, the physical model, the Wednesday after spring break, you'll bring it in. We'll line them up on the wall here, and I will grade them right there on the spot and give them back to you, because I don't want to have them all in my office. I've done that before, and the people that share my office get really cranky if I have 40 models in my office. So that's the way the grading will go. So I collect everybody's at one time. I don't grade along the way as you finish. So essentially, that's what you need for your assignment. That walks you through the whole tutorial. This same strategy with the shuffling pieces where you cut two copies and you alternate contour lines, it works if you cut it out of cardboard. It works if you cut it out of plywood. You could do it 4 feet by 8 feet and have topo out of it. The same strategy works. It's very efficient in terms of material. I've actually done it using plywood before and glued it together that way. It's pretty cool as an effect, as a really big model. So just be aware that the same strategy does work, even if it's bigger. You're like, nope, not going to do it. You can do it. You can do it in cardboard, though. It's just fine. Okay, so I'll turn you guys loose to finish. I know it's a lot to take in, and I talked for a long time today, but you've already done half of it in the last class. It's just a matter of finishing it out.